Hello everyone, welcome back to Math 1314, more on Math, Chapter 4, Section 4, Part 3. Alright, as you saw the last couple of videos, it's a lot of steps. We've however, we've gotten closer to narrowing down our possible answers. Before we started this, we could have an infinite number of combinations. But with the rational zeros, we narrowed it down to a finite set, 12 to 15 or something like that. This next method, Descartes' rule of signs, will narrow it down even further. Remember, first off, Descartes, remember him? Rene Descartes developed the X and Y charts, the Cartesian coordinate system. Same guy. So, this method further narrows our possible solutions by indicating the number of positive and negative solutions. Now, how does that help? Remember, when we had the rational zeros, we had a whole series of possible numbers. Like last time we had 15, 30 possibilities, 16 possibilities. With this, Descartes' rule of sign does is, let's say it tells us that we have 4 positives. Let's say the degree is 6. If there are 4 positives, then we know there are 2 negatives. So once we find the number of positives, then we don't have to do the rest of the list. For positives, all we do now is only narrow it down to negatives. So we could cut half of the list out. So that's what this one does. Alright, so here are the steps. Descartes' rule of signs. Step 1. Write the exponents in decreasing order. X to the 5th, x to the 4th, x to the 3rd, x squared, then x, then a constant. No zero terms are written in. Remember when we did synthetic and long division, we had to put zeros. If x squared was missing, we had to put a 0 in that column. Nope. It is what it is. The constant term cannot equal 0. If it equals 0, you can't use this method. What you can do is factor out a common variable till you do have a constant term, and then only use this for what's inside the parentheses. But you cannot have an equation with no constant term. Then once you satisfy all these, look only at the sign changes. Between each coefficient. as you read left to right. Here's an example of what I'm talking about. In the first ones, this one's positive, that one's negative. So there's one sign change. This one's negative, negative, no sign changes. Negative to positive, that's one sign change. Positive to negative, that's the sign change. So we have a total of 3 changes. Alright, so that tells us the number of positive answers. It's a little bit more than that. We'll have 3 or 1 positive solutions. But I'll talk about that in a second. But that's what we're talking about, sign changes. Look at the coefficients. That's positive, that's negative, that's one sign change. That's negative, that's not a sign change. Negative to positive, sign change. Positive, negative, that's not a sign change. So that's what we're looking for. Also, note, if the exponent is odd, and you have a negative inside there, then the answer is going to be negative. If you have a negative inside it and it's even, the answer is always going to be positive. So if I had 4x cubed, or x to the 5th, and I did 4 negative x to the 5th. Since this is an odd power, that's negative. That means the sign in front changes. So this negative comes out there because it's odd. Negative x to the 8th power, since this is even, this negative disappears. So this is in case we have a negative or positive inside of parentheses raised to a power. This is going to be important because when we do these sign changes, we have to take positive x and we have to take negative x. And here's an example. Find the number of sign changes. Yeah, the computer's going to call it variations, but they're simply sign changes. Whenever you see the word variations, that's sign changes for this polynomial. 2x to the 5th minus 3x squared plus x plus 4. For the number of positive solutions, which one S? I think, I don't know. So for the number of positive solutions, we just look at the original equation. And look at the sign changes. So it's positive to negative, that's 1. Negative to positive, that's a sign change. Positive to positive, no. So we have 2 sign changes. Which tells us we will have 2 or 0 positive solutions. Now, that's for the positives. For the number of negative solutions, we plug in negative x inside there. So we have 2 negative x to the 5th. So anywhere I see an x, I put a negative x in there. So remember what I said earlier. If you have an odd exponent in this case, it changes the sign of the answer. So if it's an odd, it changes the sign of the coefficient. So it's negative 2x to the 5th. If it's even, nothing changes. Just drop the parentheses. This is to the first power, so it changes. So it's negative x. So negative to negative, nope. Negative to negative, nope. Negative to positive is 1. So, since it's only one change, therefore we will have one negative solution. Alright? So that's what it's telling us, is we look at, for the regular polynomial, look at the sign changes from the first to second to third, third to fourth. And then change all the x's to negative x. Put those inside the parentheses. If it's an odd exponent, the coefficient changes sign. So that negative 2 becomes a negative 2, and it's just x to the 5th. It's even, so negative 3 stays there, just drop the parenthesis. Notice how after I looked at all those, there are no more parentheses. So that's what we're doing there. Now, with the Descartes rule of signs, the number of positive solutions, or zeros, is actually it's going to be either or, is either the same as the number of variations in the original P of x, or it is less than the number of variations in P of x by a positive even number. So, if 6 variations, then 6, 4, 2, or 0 positive solutions. If 5 variations, then 5, 3, 1 positive solutions. So it's whatever number you have minus 2. And you keep on going down. The reason for this is because if there aren't that many positive solutions or negative solutions, that means the remainder part has to be taken up by imaginary numbers, the i's or the radicals. And those always come in pairs, remember from earlier? They always have to have a conjugate pair, so that's the reason we subtract by 2. Alright, so the next part. The number of negative solutions, or zeros, is either the same thing. The same as the number of variations of P with negative x, or less than that number by n less than that number by a positive even number. All right. You remember, we also have zeros with multiplicities, so that's going to be addressed a little later. Let's look at some examples. So again, what the Descartes rule of sign does, it tells us how many positives or negatives, which further narrows down our number of possibilities of answers we can have. Two x to the 5th minus 5x squared minus 5x plus 6. Let's look at the number of positive or negative zeros. So the positive zeros, we take the original function. Positive to negative, that's one change. Negative to negative, that's not a change. Negative to positive, that's one change. So add those, I get 2 changes. So we have 2 or 0 positive solutions. Now for the negatives, I put negative x in there. So 2 times negative x to the 5th minus 5 negative x squared minus 3 negative x plus 6. Again, if it's an odd exponent, that changes the sign of the coefficient. If it's an even, everything stays the same. So if there's nothing, it's 1. So it's an odd, that means it's negative changes that. So this is our new, so look at the changes. Nope. 1 change, If you only have one change, then that has to be the right one. So we have one negative solution. Out of the 5 possibles, we'll have one negative, 2 positive, or 0. That means the other ones have to be made up of imaginary numbers. Let's look at how that does. We can have positives, negative, and complex. Also, remember, we can also have zeros. This only happens if we have a single x term. If all the terms have an x in common, then we have a 0. Because if we plug in 0, then it's 0. Now, our total, in this case, has to be 5. Since we have no constant terms, we can have 2 positives, we'll have 1 negative. If you add these up and down, that means we have to have 2 complex terms. Okay, this next one. We have no zeros. What if we had no positives and 1 negative? That means we're going to have 4 complex terms. Plus 4 plus 1 plus 0 plus 0 equals 5. So this is how we look at these things. Let's take another example. P of x equals 5x to the 4th minus 3x cubed plus 7x squared minus 12x plus 4. Let's look for positive solutions. So we have, I'll rewrite it. 5x to the 4th, 3x cubed, 7x squared, 12x plus 4. So, from positive to negative, that's one change. From negative to positive, that's a change. From positive to negative, that's a change. From negative to positive, so we will have 4 or 2 or 0 positive solutions. In other words, they could all, since it's a 4th order, they could all be positive, half of them be positive, or none of them be positive. How about the negative solutions? For the negative solutions, we have to put negative x in there. Negative x to the 4th minus 3 negative x cubed plus 7 negative x squared minus 12 minus x plus 4. Since that's an even exponent, nothing changes. I just dropped negative and dropped the parentheses, since it's an even. Since it's odd, that changes the sign in front of the coefficient, drop the parentheses, and I have that. This is even, so I just drop the negative in. So this is 1, so it changes the sign to a plus 12x plus 4. Positive to positive, nope. Positive to positive, nope. Positive to positive, nope. Positive to positive, nope. So we have no negative solutions. All right, so let's look at all the possible answers here. We can have 0 as a solution. A positive, negative, and let's say complex. Remember, since the degree is 4, it has all these columns have to equal 4. So, since x is not on each term, 0 cannot be a possibility. We can have 4 possibilities. That means we have nothing else. There's no zeros. We can have 2 positives. Again, we have no negatives. That means we have to have 2 complex. If we add these straight up, we equal 4. So that's 0. Or we can have 0, and there's no negatives. That means we'd have to have 4. So these are the possible combinations of our solutions. All 4 of them could be positive answers. We can have 2 positives and 2 complex numbers, or all 4 of them could be complex. Notice what this thing tells us. Remember on our rational zeros, we don't have to do the negatives. Since there's no negative answers, all we have to do is the positives. So we've cut those in half. Again, that's the whole beauty of this. It just made it all half for us. All right, let's look at one more example, and that'll do it for this section. P of x, 6x to the 6 minus 2x squared minus 5x. Notice that all of these terms have an x in common, so I can factor out an x. So that means if I take out an x, I subtract these by 1. And that one's gone, so it's just 5. So because this x is out here, we know one of my solutions has to be x equals 0. So all I do now is I look at this. Positive solutions. 6x to the 5th minus 2x minus 5th. So positive to negative, that's 1. Negative to negative, 0. We will have one positive solution. Remember, if it's 1, it can't go down any further, so we'll have one definite positive solution. So for the negative solution, I put a negative x in there. 6 negative x to the 5th minus 2 negative x minus 5. Since this is an odd exponent, this negative moves out in front, so it's negative 6x to the 5th. This is to the first power. That negative changes to a positive 2x minus 5. Negative to positive is one change, positive, negative is another, so we have 2 changes. We will have 2 or 0 negative solutions. we use our table. Remember, we have 0 as a 0. We have positives, negative, and complex, or non-real. Since the power is 6, each of these columns have to equal 6. So remember, we had 1, 0, so that has to be there. We have 1 positive, so that has to be there. So we can have 2 negatives. It's 2, 3, 4. We have to equal 6. So we'll have 2 complex numbers. Add those up, equals 6. Remember, this is either 2 or 0. So 0 is 1, positives is 1. What if this is 0? 1, 2. So this one has to have 4 complex numbers. Or this equals 4, 5, 6. So if we have 0 negatives and 1 positive, 1 definite 0, that means we're going to have 4 radicals or non-real numbers. Alright, that took a long time. So this section here was the longest of all of them. This is the middle of the topics, so now from here on out things get easier, shorter. I hope. Alright, good luck everybody.